Hello, I am forecaster Nick Dunn reporting, and I appreciate you tuning into this special presentation on the Bellpark Weather Network. Today we're going to be comparing the tornadoes that hit Dayton in 2019 with the tornado that hit Nashville earlier in the month of March during 2020. This video is part of Bellpark Weather Network's Severe Weather Awareness Week. In this video, you will see a full breakdown of the tornadoes that hit Nashville and Dayton. We'll talk about the average number of tornadoes that happen across the United States. We'll do a breakdown of the atmosphere for you and show you the time of day these tornadoes struck and the atmospheric setups that were in play. We'll also talk about the storm surveys for each of these tornadoes, the Storm Prediction Center outlooks that were issued for these storms, and the lessons that we learned from these storms. Looking at the average number of tornadoes on a national scale, as you can see, the most tornadoes every year occur in the month of Texas on average, with 146 tornadoes every year. Ohio averages 19 tornadoes, and Tennessee averages 29, and nationally we average roughly 1,224 tornadoes, and this average is looking from 1991 to 2015. During the month of March, statistically it's not very busy for tornadoes. We do see about 75 though, so it's not uncommon, and that is when Nashville was hit with the tornadoes during the month of March. When we look at 1991 to 2015, Ohio averages 1 tornado every March, while Tennessee averages 3 tornadoes every March. The month of May is when Dayton was hit with tornadoes, and this is a much busier month for tornadoes statistically across the nation with 269 tornadoes. So as you can see, that is more than 3 times the average for the month of March. Ohio averages 3 tornadoes every May, while Tennessee averages 6. Next up, let's look at the atmosphere for each of these tornadoes. First off, we will look at the Nashville tornado. An area of low pressure was situated across the parts of the Now let's look at the atmospheric breakdown for each of these tornadoes. We'll talk about different things that were happening in the atmosphere and how that contributed to the tornadoes. First off, looking at Nashville, an area of low pressure was situated across the Ohio Valley, with a warm front extending from southern Kentucky into eastern Tennessee. This warm front played a pivotal role in one single thunderstorm that developed across western Tennessee and moved across most of the state, producing a wide swath of damage from hail, destructive winds, and tornadoes. Instability was not very high given the month. March is not typically a month we see a lot of instability across the area, but shear was very efficient. Shear is one ingredient that thunderstorms need in order to survive. Looking at the Dayton tornado, this setup I'll spend a little bit more time on because it happened in a different time of the year. May is a time of the year that we start to see much more instability, more moisture, more lift, warmer temperatures, and it played a little bit of a different factor in terms of what happened across Indiana and Ohio. There were numerous tornadoes that took place from Indiana into Ohio on Memorial Day of 2019. Dew points were in the 60s and 70s, so a much more impressive setup combined with much higher instability and very efficient shear. There was a warm front here, and while that did not really aid in the tornado that hit Dayton, it did help keep the area very unstable and produced numerous thunderstorms that were capable of and actually did produce tornadoes across Indiana and Ohio. This setup compared to Nashville was a little bit different, as the warm front played a bigger role in the Nashville tornado compared to the Dayton tornado. Now let's take a look at the Storm Prediction Center outlooks the day before each of these tornadoes hit Dayton and Nashville. First off, Dayton was under a marginal risk the day before the tornado hit. A marginal risk is noted as the lowest severe weather category. There was not a mention of tornadoes really occurring across the Ohio Valley, but as always, tornadoes are possible with any severe weather event. A higher risk of severe weather, noted as a slight risk in the area in yellow, was noted across portions of the Great Lakes and into the Great Plains. Looking at the Storm Prediction Center outlook for Nashville, a marginal risk of severe weather was indicated for much of the middle Mississippi Valley, including the city of Nashville the day before. Both Dayton and Nashville are marked here with black stars on each of the outlooks. Moving ahead now to the day that the tornadoes happened. As of the afternoon update from the Storm Prediction Center, Tornadoes were looking like to be a pretty good possibility across parts of the Great Lakes and into the Ohio Valley region, as the Storm Prediction Center indicated a 10% chance of seeing a tornado somewhere in the northern Illinois, northern Indiana vicinity, and a couple of those tornadoes could even be strong. Dayton was under a 2 to 5% chance of seeing a tornado happen within 25 miles of any point. Meanwhile, looking at Nashville, as you can see, just a 2% chance of seeing a tornado was maintained by the Storm Prediction Center, and a higher tornado risk was indicated just to the west of the city of Nashville. Off to the right-hand side, you can see how each of the percentages and the probabilities correlates to each severe weather categorical risk, ranging from marginal at 2% to a high risk at 60%. As storms evolved in the Dayton area on the night of May 27, 2019, the Storm Prediction Center increased the probability of seeing tornadoes. In fact, the Storm Prediction Center increased the tornado probabilities to 10% for parts of western Ohio and eastern Indiana, and there was even mention of strong tornadoes happening. Tornado probabilities were also increased for more of Ohio and Indiana to 2 or 5% respectively. It should be noted that a 10% probability of seeing tornadoes does not happen very often in our area, which also helped to raise the awareness of how severe storms could become. Looking at how storms evolved in Nashville, as of 9 p.m. on the night of March 2nd, a 2% tornado probability was maintained for the city of Nashville. This is the lowest percentage or probability used by the Storm Prediction Center when talking about the chance of seeing tornadoes. The highest probability of tornadoes was to the west. However, anytime you are under a probability of tornadoes, it is always mentioned that you should be prepared. Also, there was no mention or talk about a strong tornado or strong tornadoes happening across this area. Now let's look at how the Storm Prediction Center did in their forecasting. As you can see, looking at the Dayton tornado, the Storm Prediction Center did a really nice job showing where tornadoes were possible against how the tornadoes actually performed and where they happened. Each red dot here on this map represents a tornado, and all tornadoes happened within the 2, 5, or 10% category denoted by the Storm Prediction Center. When we look at the Nashville tornado that took place, there were several tornadoes that happened in the 2 and 5% area. However, some tornadoes did happen outside of the 2% tornado area, and in fact, an EF4 tornado hit the city of Cookeville, which was outside of the 2% tornado risk at that time. This goes to show that storms can perform in strange ways, and that you should always be prepared for storms to perform erratically, and be prepared whenever severe weather is possible in or around your area. One other thing that I wanted to look at, especially when we talk about severe weather, you like to hear us talk about the significant tornado parameter. It is just one thing that models look at, and it's one thing that we look at to determine just how significant an event could be. This stuck out to me, and I thought it was important to share and kind of cool to share as well. As of 7 p.m. on the night of the Dayton tornado, the significant tornado parameter was as high as 5 across parts of Indiana. This really stuck out to us, and we know now going forward that when we see values of that magnitude, that significant tornadoes are possible if everything aligns correctly in the atmosphere. With sunset approaching, the event looked particularly dangerous with tornado parameters of this magnitude. I just thought that was kind of cool to share with you. Now let's look at the radar for each of these storms and what they looked like on radar and their locations given the location of the storm versus other thunderstorms in the area. As you can see noted here on the radar from the Wilmington National Weather Service office, the storm that produced the Dayton tornado was on the southern end of a complex. You can see the blue arrow there pointing to the storm that the tornado occurred that hit Dayton. This allowed the storm to be isolated with no interference. As you can see downstream in places like Springfield and Xenia, not much activity was occurring. Therefore, this tornado was able to maintain its longevity and its intensity for several miles. When we look at the tornado that hit Nashville, it should be noted that this storm actually developed during the late hours of March 2nd, 2020. This storm sustained itself well into the overnight hours, and that even included into the early morning hours of March 3rd. Looking at this radar image, you can see that this storm, just like the Dayton storm, was very intense on radar. It was a supercellular thunderstorm, And unlike the Dayton tornado, which had instability and shear and very high moisture available to sustain itself, the Nashville tornado actually was part of a warm front that was lifting through the area. This warm front interaction allowed this storm to sustain itself and remain discrete and rotate. Next up, let's look at the storm surveys on each of these tornadoes. Starting with Nashville, the storm started at 12:32 a.m. with a tornado west of Nashville, and it lifted well east of Nashville at 1:35 a.m. Central Time. It was rated an EF3 with winds of 165 miles per hour. It was on the ground for over 60 miles, and it was 800 yards wide at its peak. 220 people were injured and 5 people were killed in this tornado. Now let's look at the Dayton tornado. The tornado occurred on May 27th of 2019. It touched down at 10:41 p.m. and it lifted at 11:13 p.m. It was rated an EF4 with peak winds of 170 miles per hour. It was on the ground for 20 miles and it was over 1/2 mile wide at its peak. Over 300 people were injured and 1 person was killed as a result of this tornado. Tornadoes avoid urban areas. We've all heard this one before, and some of us may even think that tornadoes do avoid urban areas. One similarity with these two tornadoes is that we can show you tornadoes do not necessarily avoid urban areas. It is a common phrase that many of us hear as we're talking about tornadoes, and as we can see here, Nashville has been hit by multiple different tornadoes. There are 3 different tornadoes that have hit Nashville since 1933, and in fact, there is even an area where all 3 tornadoes came very close to crossing each other. Tornadoes hit Nashville on March 3rd of 2020, March 14th of 1933, and April of 1998. When we look at these 2 storms, this shows that tornadoes can strike metropolitan areas, so always be ready no matter where you live. Now let's start to wrap up this video by talking about some of the lessons that were learned. In both instances, some people may have been caught off guard. In Dayton, with it being a holiday, some people were likely returning home from Memorial Day activities and travel, and perhaps their awareness was not as high about severe weather. Some were still awake, though, as this tornado hit before midnight. However, some people were asleep when the tornado hit. In Nashville, many people were already asleep, and it's very possible that they were asleep for several hours, as this tornado hit after midnight. The number of people awake was likely much less compared to the Dayton area. This likely made the process of getting warnings more difficult. Dayton has very few tornado sirens, making it difficult for those outside to get alerted. The fact, though, is that several storms in the area produced tornadoes, which helped raise awareness that any storm was capable of producing a tornado, given the atmospheric environment in the area. Nashville has several tornado sirens in comparison, but in the middle of the night, it's very unlikely that many people were outside. Although the fact with that storm is that it produced damage and tornadoes prior to hitting the city of Nashville, which helped those at least be aware of a thunderstorm in the area, for those that were awake. A weather radio. Some of the biggest things that we're noticing is that, well, more people need to have a weather radio inside their home. Also, everyone needs to have more than one way to receive a weather alert. Storm Prediction Center outlooks. These are very important in communicating when severe weather is possible. Several people still do not understand how these outlooks work or what the risk levels mean. Understanding the outlook should help you prepare for severe weather. These outlooks are updated several times during the day of an event. Knowing your risk level is just as important as knowing when there is a risk of severe weather in your area. Just because you may not be in the bullseye does not mean that you won't see bad weather. And here's an interesting tidbit for you. Tornadoes are not smart enough to abide by the outlooks issued by the Storm Prediction Center. Tornadoes do not just happen based on the risk level or percentage of a tornado happening, and tornadoes do not follow the various risk levels given over an area. Being prepared is the best policy. Having multiple ways to receive warnings is important. One method is not always effective. Having more than one does not hurt. Understanding the risk levels. It is very important to know what each of these mean. You have everything from general thunderstorms all the way up to high risk. Each of these risk levels carries with it an understanding of how severe storms could be. You could have isolated, scattered, numerous, or widespread severe storms. There are 6 categories used during the thunderstorm days to predict the severity of such thunderstorm activity. Storms can have erratic behavior and can overperform and be stronger than the forecast calls for, so always be ready. Thank you for tuning in to this special presentation. We hope you found this very informative, and we hope that you will be staying tuned for more updates on severe weather this season across the Ohio Valley. I'm forecaster Nick Dunn reporting, and thanks for watching.